It is time for our last. Recording is now in progress. It is time for our last session of the day and of the conference. A short session. We have only 2 more talks. And the first one is by Takanobu Nakamura on cumulative questions on structured and structured schema.
Thanks, Elaine, and thanks for all. And it's a pleasure to be here. And I forgot to shorten the slides, so I will cut down. I will speak quite rapid manner, but you can read the handout if you missed or you need to. So I focus this kind of questions and pairless responses or answers to this. If you ask who do the students like, you can respond to this by saying unlikes Professor Jones and then likes Professor Smith. And I think you can answer this in this way, but it's controversial if this is an answer which is semantically enabled or responses which is not semantically enabled, but speaker choose to be over-informative and follow up by specifying the pairs. And Krivka and Srizpa's staff chose the latter path and saying who do the student like has a cumulative denotation, namely give me the set of people such that each of those people are liked by at least one student, and each of the students like at least one of those set of people. So it doesn't specify the correspondences, but you can respond to it. They like them. By the way, this is the correspondences. And this is one way to respond it, but you can do it in different ways. And as you can see, you have a quantification over the members of the student, and it's essential for Jones and Smith and vice versa. And it doesn't pick out one exact correspondence, so it's too weak to derive quantitative reading. And fine, this kind of thing is in any way necessary for cumulative readings or plurals, so you don't need to analyze anything else to analyze this kind of question. But Johnston says this is too simplistic because he wants this in this context in which coach already knows who the players are and which the numbers are. And he also knows that every player picked one number and every number is picked by one player. So cumulativity is already satisfied. And as you know, the players, who are the players is not a good question to ask here because you already know it. But you can ask which numbers did the players pick to seek all the information of correspondences between them. So cumulativity is too weak because what you want to know is already entailed in the context. So Johnston argues this is semantically enabled answer. It's not pragmatic over informative follow-up. And he chose to enable it by choosing the cover distributivity operator, which can be taken as a cover version of each, which is also motivated in the literature of distributivity. And I don't talk much about this, but it's also independently necessary. So you can see this is parsimonious. But then I don't like it because this will wrongly predict the number sensitivity of the average questions, comparing definite plurals and quantifiers. And look at the 3 questions. Which professors do the students like? The original question, and you can respond with pairless. And which professor do the student like? It's harder to get pairless reading, and it sounds like there's one professor that those students like. But if you say which professor does every student like, now you can have a pairless answer. And I forgot to put it here, but analogous result can be obtained by saying which professor does the students each like. And that's exactly what people want to say by inserting cover distributivity operator. So that's the problem because 5 should be fine to be answered by B if Johnston is right. So I still think Johnston is right that cumulative analysis is too weak, but still Johnston is too strong in the sense he blurred the distinction between quantifiers and definite plurals. So I will propose an alternative by saying you need something called structured witness set, which is an extension of witness requesting set proposed by dynamic inclusive semantics. And the idea is, as long as you have a quantifier dependency stored in the context, you can have a pairless answer. And pluralities and distributivity are 2 different ways to store dependencies, but they are still different. And there are some nice data. And this is a disclaimer. I don't have very fancy analysis because I don't have time. So I will just have very simple coherent semantics based on dynamic plural logic defined by Van den Belle. and others. And you can extend it in a fully inclusive setting. And there are some blah 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 in the appendix. If you want to read it, you can read it. I don't think I have time to read it to do it here. And roadmap, not very informative. So it's super quick. I think you already know, so you don't need my introduction. And if you are really onto it, maybe I cannot provide, so I can't be very well. I'll be quick. So in short, dynamic semantics, I will discuss different as a fancy term for variables, and information state is I will call variable assignment as information state, and you can roughly take it as information state Z, in which the draft U1 has a value Aki and U2 has the value B, and creates a different information state assign different values. And today I will take a set of variable assignments as an evaluation point. And the objective is now you can see the correspondence between these people in this column, and these people in this column, and these people in this column. And you can obtain the plurality of Greg, Hannah, and Irene by summing up the values of U3 spread across G. And this is an abbreviation for that. And now I can define dependency on this. In short, UM is dependent on UN if and only if there's a covariation between them. And you don't need to be fully covariant, but U2 and U3 are both dependent on U1, because you can see if you replace the value for U1, you can see the value changes in U2 and U3, but U4 remains the same even though you change the value for U1. So U4 is not dependent on U1. And this is an assignment extension. The UN versus the new value in H. This whole if and only if G and H minimally differ in terms of the value on on UN, and other variables have the same value on G and U. And I have to generalize it over a set of variable assignment in this setting. And this is one way to do this. So it's a point-wise extension of assignment extension for set of information state. And the point of taking this is now you can introduce new dependency by assigning new value spreading across different line pairs of set of variable assignment. So here this is dependent by definition, and this is not dependent by definition, and both are allowed by this. And then I will build a very simple equation semantics based on this setting, and I will take a context as a set of possibilities, which is a pair of word, and this time a plural information state. So word and a set of variable assignment, and the context is a set of these possibilities. And this is notation for dynamic conjunction, it's that function composition, and this is assignment extension rewritten in this setting. And I will fully follow Brazzavenu by saying lexical relation is evaluated distributively in the sense each information state in plural information state stored the tuple which is a member of representation of R. And those atomistic conditions are defined collectively in the sense this has to be true for the sum of values across plural information state. I will come back to this later. And the last bit, well, not the last bit, but last housekeeping part. This is the distributive operator delta, and in short, this will distributively evaluate phi with respect to subsets of plural information state. So imagine G stored x1, 2, 3 on U1, and this will split this into 3 subsets based on the value of U1. And phi is evaluated with respect to this and this and this. For example, imagine there's assignment extension for U2, and it assign a singular value. But this assignment of singular value is done for each of them. So if you come back to the plural information state, you store plural value. So atomicity is defined as a collective condition, but the atomicity itself is iteratively applied to each subset. So even though it's atomic, in the global level, you can store plural value. And so far, this is more or less like standard or safe assumptions in dynamic plural semantics. And this is non-inquisitive, well, inquisitive, a notion in inquisitive semantics, which is rewritten in partition semantics way. So this operator split the context based on the value of draft U. So for example, take a question, Fu smiled, and Fu can assign different value based in different possibilities. Imagine Anne and Bill are two possible values, and you split context into Anne smiling word and Bill smiling word, both smiling word, no one smiling word. So it raises an issue in the sense now context is split into 4 different parts, and you can answer this question by providing one of them. In short. Okay. I just keep saying things, but this is a kind of what has been done in some way. And this operator cannot derive what I want because this is just sensitive to the value of the other way around, value of U, which is it's not sensitive to dependencies. So if you just apply this to which professors do the student like, you can't get a pairs answer. So what I will do is to make it sensitive to dependencies, and I call it structured witnessing operator. And we'll say that can solve Johnson's problem without running into Krivka's problem. So in short, instead of splitting the context based on the value of U, let's split the context based on the function from the value of U to the value of other dref, which it is dependent on. And if G is singleton, it's not different from the original operator. But if this is not singleton and store some dependencies, now that will split the context in different way. And I think it's better to look at the example. And this is the original example, which professors do the student like. And it's not that informative, but wait. Imagine 4 very simplified setting about 4 possibilities. In one possibility, you Anne like Jones and Ben like Smith, and Ben like Smith, Anne like Jones, and Ben like Jones, and so on. And now they are dependent, or this is not dependent. And if you look at the functions, they store Anne Jones, Ben Smith function. So they are grouped together, they form one state. And this form different function. So this is put in different state. And here, U2 globally store just one individual. It is atomic. And now this conflict with the number of which, because it has to be no atomic at the global level. So this possibility doesn't go through the test, doesn't survive through this update. So the result is you raise an issue in regard to the functional dependency between Anne, Ben, and John Smith. And importantly, this and this are put in different states. Namely, these are 2 distinct answers to the issue. So now you can derive pairless answer for the question. And essentially, you don't need to insert delta operator to analyze this, which caused the problem for number sensitivity. And that was plural version. And if you say which professor do the student like, now you have to put atomistic condition for professor because that that's marked singular. And if you look at the same information state, now only this possibility satisfied atomistic condition. And to get pairless leading, you have to have a plural value on U2. So it's trivial, but you can't have pairless answer here. So number really matters to get a pairless answer. But if you have a quantifier, now you have a delta operator here. And if you remember the part on delta operator, this atomistic condition is evaluated with respect to each subset of, well, information state, which agree on the value of student. So now you check for each small g, the value of U2 is atomic, and that's trivial here. Everything satisfies this, including this. So the result is they have one state, and this is one state, and this is one state. So you have 3 possible answers for this question. So now, even though the rate itself is singular, as they are under the scope of delta operator, which distributively update the context, you can get a pairless answer. And I think that is, in spirit, the same as classical ways to analyze pairless answers. Yeah, so I think I said everything. I don't know. So that's how pairless answers are derived. And the important point is pairless answers are derived in different ways for plurals and quantifiers. And quantifier evaluate atomistic condition under the delta operator and derive the pairless reading. But for plurals, there's no delta operator, and you can just derive pairless answer by splitting the context based on the function. And there's actually a data which support this kind of analysis. So, okay, in short, Shan also has an alternative. She doesn't like Johnston too. And she instead says, well, you don't need this operator, but you will have other covert operator called RESP, which is roughly taken as a covert version of respectively. And that can't be the case because originally RESP operator is proposed for things like Tolstoy, Dostoevsky wrote Anna Karenina and the Idiot respectively. And RESP operator is supposed to be responsible for this kind of predication. And you can do this kind of thing with non-conjoined plurals like 23b, but just distinct plurals can't really participate in this kind of predication. And most importantly, which numbers did the players pick respectively is not a really fine way to ask the question. And this is not expected if you put covert version respectively. And you can still say, well, for some reason, you can put RESP operator. Then let's see if that derives the right result. And here, importantly, you have a universal quantification over the index of in the ordering, and the property P is put under the scope of that quantifier. So if you have some singular indefinite here that we predict, you enable covariation of single indefinite, just like every student wrote a paper. You can have different paper for students. And in my analysis, there's nothing like this. So acceptable, like ease of getting the covariation should be the same as saying that students wrote a paper. And there are like some experimental results by Dr. Churchill saying like it's hard to get a covariation reading of a singular indefinite with non-quantification plural. And if you compare these 3 questions, which cities did the guys recommend to a customer? It's hard to get a pairless reading here. It sounds like there's one customer such that different guys recommend different cities. And you can do the same thing. I don't know. I have some slides, but well, I'll tell me later. And this reading can be is fine with plural customers, or if you say every guide recommend to a customer. So this is not, again, this is not expected for Shan because she has to quantify over singular indefinite. So, and the same thing applies to Johnston because he put this operator. Okay, fine.
So you know.
Okay, so, but almost done. So, in short, you can derive a pairless answer without having distributivity there. And that is good if you can't get a cooperation reading of singular indefinite between infinite plurals and WH. Okay, I have 2 seconds. So, but by using the 2 seconds, I'm not in a position to say you can't insert this operator because that is in any way necessary to get cover distributivity. And there are some speakers who accept singular, like cooperation reading singular indefinite, but that speaker accepted the pairless answer with the singular WH, and that is exactly what is expected if Johnston is right. So that's I still have to think about this, but probably Johnston's strategy also works, but that doesn't come for free. And if you have a judgment pattern reported in here, then you still need something else, and dynamic semantics can do it. Okay, sorry, it was messy, but I'm done. So thank you for listening.
You have about 9 minutes for questions.
Thank you. That's very interesting. So in the talk you only dealt with object established questions, and I was wondering how this is supposed to work for example, subject established questions compositionally.
Yes.
So in your account, my take is that the double word has to somehow depend on the other era of introducing expressions in the sentence. But if the double word is a subject itself, how is it going to know which variable I am supposed to depend on?
Yeah, so originally I was thinking about saying you can arrange the system which has one variable and you can satisfy that condition for one variable. But in this system, that it's really hard to implement that in the system and it with my brain. So at this point, I have to say some handwavy thing like you are allowed to be uncorrect to itself. And in that case, the function is reduced to the identity function, and that is equivalent to the original witness requesting operator. And I don't think that's true, but at this point, I can't offer anything better. But still, this kind of asymmetry is reported in Johnston, and now I'm trying to do things without, movement and trace. But if you say it's anaphoric in some sense, this follows because you have to associate from left to right in this case.
So the sharp on 38A. The sentence is infelicitous?
So this question can be asked, but this question cannot have a pairless answer. So in the original context, this question cannot be asked because you already know the players, and there's no path to enable pairless answers to this question. Sorry.
Yeah. Okay, that's a good answer. Thank you.
We have a question in the chat, so I'll just read that. So I read it. This is from Vincent Zhang. Thank you for this talk. It's really interesting. Sorry that I missed part of your talk. How about which professor recommends which student? The VPs are all singular, but I think there's still a pairless reading.
I'm sorry?
The VPs are all singular, but I think there's still a pairless reading. The sentence is, which professor recommends which student?
Which professor recommends which student? So yeah. Actually, I have a part. So I'm not trying. I'm going to do it. Yeah. So if you have not multiple double questions, you have to I apply different analysis for multiple double questions, and my analysis will be a version of Dr. Rachel and Laurifson's analysis, and that analysis will not impose any number restriction for, okay, this is not a slide, but it doesn't have a number condition for WH, but oh wait, it's which professor recommend which students? And it has fairly answers. Okay. Well, so thanks for the data, and I don't know how to do it right now, but you can say this is a kind of telescoping case, but I need to look up the pattern, like in which condition, or like how robust it is to get pairless answers with singular WH. So yeah, I cannot satisfy you right now, but thank you for the question.
Other questions?
Thank you for the talk. I'm not sure whether I fully understand your theory, but I'm curious about whether your theory distinguishes pairless answer and the function answer, or not.
Yes, I thought about that 2 days ago, and I decided to postpone it.
Okay.
So like one way which I'm not fully satisfied with is like saying just following care and saying functional answer is a kind of pairless answer which specifies the name of the function instead of like spell out the members of the function. But I don't have a way to explain the difference of distribution of pairless answers and functional answers. So that's all I can say right now.
Thank you.
But thanks for the question.
Others? It is possible that people run out of steam a little bit at this fast movement of the conference. Well, let us thank our speaker again.